Okay, for people joining this live stream, we are talking about incremental language development for Wolfram Language, and we have a variety of topics today. Let's start with curry and reversed.
So this is another iteration to the design of curry and reversed, which are very close to each other. So what we agreed last time was the first lines of each of them. So effectively that, yes, that reversed would take 2 arguments, and then it would be generalized to multi-arguments, which is a very useful thing. But then
By the way,
has...
I assume that we like the word reversed and we don't prefer something like swapped to avoid a confusion with reverse itself.
I do like reversed because swapped seems to suggest two. And precisely
right, okay.
that's
Fair
the
enough.
discussion.
And this is actually quite nice. Okay, so that's a good idea. Yeah, that's cool.
Yep.
That is cool.
Indeed. Because many people sometimes say, oh, I want the opposite convention for this product. And it's so easy to reverse it with that.
Nice.
Right. So that's a good thing. And that's why I'm still suggesting we go that route. But in discussing with Roman, he is still unhappy that the default of carry F is reversing the argument. So something he suggested is the last line of the first section, which is that instead, what we could do with the one argument carry is to carry itself.
I understand.
So that would be an alternative, which I understand is kind of very clean from the theoretical point of view. But then the problem is, and then how do we do what we currently do with carry of F? And that's a third section, the combination.
Why isn't it just reversed of F? Isn't that the same thing?
Well, we want something that is carryable, because carry of whatever will then be used in carried form with just one argument. And we were not planning to carry reversed. And that's the problem. We can either carry it or make it vararg, but not both things.
I understand. Okay. So let me just understand something. So if I say curry of F of X of Y, it's going to be F of Y of X, YX, like that.
Right.
Right? Do we have a version of reverse that's runnable?
No, but it's sorry, I always forget to send you the easy.
Is curry still tagged as experimental?
Yes, it is. And precisely that's why we are still discussing its basic design.
Okay. So reversed of F of X of Y turns into F of YX.
Right. But it's not carryable because being vararg, we want it also to work on 0 and 1 arguments. So we cannot say reversed of F of X and of Y.
Right, so that just does that.
Exactly.
Okay. Okay, so now what's the... But so I'm confused why curry of F of X Why doesn't curry of f of x? What the hell? Why is it going to infinite loop? Oh, why doesn't that just turn into f of x? Why am I confused here?
No, because carry of f by default expects 2 arguments, so it's there waiting for the second one.
Okay,
right? So
but
carry
that would give
exactly, or just one, just without the list. We would do it.
Mm-hmm. Okay. So is there a proposal here?
It's a matter of a choice. We either change to what Roman says of carry of n of f, but then it becomes difficult to construct operator forms, or we keep it as it is with the reversed being vararg, which right now
wait a second. Yeah. I mean, the curry, the fact that we are reversing these arguments in the curry is far from obvious that that's correct.
Yes, exactly.
I mean, it could be that the default curry is the fact that the default curry reverses, it could be that the default curry
is 2. The other possibility we have considered is carry 2. Yeah, that's equivalent to carry f comma 2.
Yeah.
And then it takes the 2 arguments and do not.
Why is this so slow? What is going on here?
I have seen this recently. Can you do $context?
This thing has just gone bonkers. Look. What is happening?
You cannot even write?
No, it's got a spinning disk. I'm going to try and quit this. Maybe this kernel got confused for some reason. It's not even letting me quit. That is truly bizarre. It says the thing isn't running, but yet it still has the notebook up on the screen. That's really weird. I've never seen that before. It's kind of a Twilight Zone thing. How could that? Oh, I see what's happening. Oh my gosh. How utterly confusing. Never mind. What's happened is that this is running in some totally bizarre prototype build.
I see.
Never mind. Okay. Bye-bye to that. Hold on. And that also explains that weird aborted thing that we saw at the beginning. Okay, no matter. Let's okay, let me also get your definition of reversed. No, that doesn't work. Oh, come on, why isn't this working? What the heck? That is refusing to let me paste. What is going on there? Weird. Oh, Devin, could you report that? This was a pasting from text into here, which I think may be similar to the problem of pasting images that sometimes fails.
Yeah, I've experienced that same problem in the past.
I mean, I think John had said something about, maybe he said he found it. I've forgotten, because I gave him some cases. Okay. All right, we're looking at okay. So why do we think curry reversing is particularly useful? I mean, if curry...
Because the vast majority of our operator forms do that. They carry the second argument. That's
Give me
why
an example. I mean, so for example, select. Yeah, select carries its second argument.
right. That I was using one example like transpose, in which the natural thing there to carry is the permutation.
Yeah.
And,
Well, to curry as in to put as the, I mean, the natural thing is curry of transpose, curry transpose of 2-1, for example, of matrix.
exactly.
Yeah, I kind of agree. I mean, we don't have Roman on this call, do we?
No, I've discussed with him, so I can defend his argument.
I mean, this is clearly a useful operation. What's going on here is clearly a useful operation.
Mm-hmm. Yeah, and he understands that. I think his point is that there could be a dedicated operator for that. But I have the impression that it's going to be too many. And I don't see, even though I see the beauty in carry n of f, he didn't send me an example of something that uses that.
What about this? What about something called curry 2 that just does the swapping thing? I mean, let's try to name. We obviously had a big hard time naming curry.
Yep.
But what if we were just trying to name this operator, the one that picks up?
At some point we had a carry swap, I think.
It's pretty obscure. I mean, what's the analog of reversed that could do this? You know, reversed means that it's taking its arguments reversed.
Mm-hmm. So I think our problem is that we need a combination of reversed and carry. And if we separated things as Roman wanted, we would have to combine them, as you see at the very end of your notebook right now.
Yeah, I understand. That's horrible. Mm-hmm. So we need a name for this thing.
Yep.
Okay, so what is it really doing? I mean, look. That's what we call it all the time.
Mm-hmm. But form is a bit unfortunate because it's not traditional form. But yeah, it's what we call it. Yep.
I think this is too general.
Yeah, indeed.
Is there anything with operate? Don't we? I think that's very general. Operate. What the heck is operate?
It's map at head.
Oh gosh, this is one of these version 1 functions that has never really panned out.
Yeah, the way I remember this function is by changing to map at head.
Maybe we should call it map at head and retire operate after long service of 30-something years. Because I agree that I will never remember this thing. I mean, I didn't remember it. Is there an operator form of operate?
No, I don't think so. We never touched this function.
That seems mildly interesting, actually, that operator form. Don't you think?
Yeah. I mean, we do have operator forms for all the cousins, like map and upthread, etc.
I know. So, okay, I mean, I think we should seriously consider having a map at head and deprecating operate. Maybe in another 20 years we can reuse the name. But at the very least, if we were still going to use operate, we should make operate have an operator form. Okay, but here,
Something to take into account is that if we have a dedicated operator form object or similar, it will need the same freedom of carry, because sometimes we want an operator form of the second argument.
Sure,
or the
absolutely.
third. So it's going to be basically like carry, but with a different default.
Well, no, it could be exactly like the curry we have now. I mean, it could be that we actually rename our current curry as operator form, and then maybe make curry do the Roman thing.
I see. Yeah, we could do that.
I mean, this would make for some reasonably readable code.
Mm-hmm. Yeah, that I agree.
I don't really like the word form there.
Yeah, it's unfortunate.
What else could we do? What other ending for operate could we have? Okay, so what we would explain here is that this is oh, look at that. Represents an operator form of the function f. Lucas on our live stream is saying that operator forms do not exist for map all and block map. That's kind of dumb. That seems like an oversight. Why would an operator form not exist for map all?
Yes, we have been adding them one by one. So yeah, we miss cases.
Mm-hmm. And block map all and block map. Okay, so let's come back to this. I wish this could be slightly shorter. Operate. Okay, so what would the code look like? So what we'd have is we'd have something like this. We haven't used the word operator in 30 years. What do we think about this as a possibility?
It's a bit scary.
It is a bit scary.
Such a general name. But it reads very well, yes. I'm thinking if one day we introduced operators, then we would have a conflict with operator forms, actually.
What kind of operators?
Let's say differential operators. So things that it's a bit like a generalization of derivative one.
Yeah.
Something that can combine differential operators without actually applying them to a function or something like that.
Yes.
I mean, it might be in the future of ND-solve.
No, I agree. I agree to be able to create a differential operator, but how would that differential operator work? I mean, it will be a thing. I mean, making curry be something that is very puristic, like having this crazy, like having it, having its one argument form be its curried, be it a self curry, seems kind of reasonable given how funky the function is to begin with.
Mm-hmm. Yes, it's a purer version. Now, for example, it's a version that cannot have defaults in number of arguments because having an empty pair of brackets would sound strange there.
Yeah, I don't know what the default would be anyway.
Right.
I mean, this is one of the many, kludges of lambda calculus and so on. You have to know how many things you're collecting.
Right.
I just have this one. I'm just wondering if there might be some mathematical, I know that means something different, but some other, operator-like name that isn't operator.
I see.
Let's see. Well, provisionally, I'm beginning to think curry of n makes sense, and that we need something here that reflects. Yeah, actually, Lucas on our live stream is suggesting something. This an auto function. That's an amusing idea. I'm so scared of auto functioning functions because of some disasters that happened in SMP with those things. But the concept here would be that, I mean, it's semantically quite kind of weird, but I mean, in other words, if you had an f of, let's say it was, @ b, that would essentially auto functionize this thing. Do you get what I'm saying?
Yes. For the one argument case, that might.
Well, it's not one argument. I mean, that would then be equivalent to this. The problem with this is that as soon as you wrap another function around this is going to go to hell. Right? I mean, as soon as I do this, it's going to wind up being g of f of that, and it's gone to hell.
Right.
I do agree. I mean, for example, yes, Ethan is pointing out that something like this already exists with a very beautiful. I mean, Christopher is a big enthusiast of this way of writing function, which I agree looks very nice. I mean, that's solving a slightly different problem, because this you still have to name the variable. All right, are we, well, let's think about how the differential operator, how would the differential operator work? It will be a symbolic thing that represents, that is like a derivative, and that would presumably, if applied as a subvalue, see, but this is exactly where my whole through and operate and all those guys came from, right? Because through, what I imagined was that one would say things like, d plus 1 of x, okay? And then one would say things like through of that, and one would get this. Right? I mean, that was intended to think about differential operators that live, operators that live in the head and that have arithmetic going on with them and so on.
Yes, this appears sometimes in the calculus of derivatives, for example. So you have f prime and g prime, and it's not easy to construct a single function that can be then applied to x.
Sure. Right. Well, I think we should Ethan on the live stream is mentioning things about the scope constructs from general utilities, which I do not know anything about. Does anybody here know about those?
I don't.
Good thing for us to look at. I don't know about them. Scope and module scope. Devin, maybe you could
I will
add those to some. Okay, anyway, so look, the one question here is, do we want to call this operator? I don't know.
I think it's too general.
Well, come up with another suggestion.
I haven't. That's the problem.
I almost would prefer operator form to operator.
Yeah, well, I kind of agree. What's that?
No, I do too. Other than that, form often has a different meaning in the language. I still would prefer that.
Right. My question is there any other ending for operat, so to speak? Operating, operated, reversed. I mean,
I was wondering about operated.
I don't think that quite works.
No.
I mean, unlike reversed, which does work. I mean, the fact that the documentation says operator form is a little hard to escape. Well, so it's either operator or operator form.
Okay, so I suggest that let me try to implement this new version of Curry for next week and see if it all works correctly.
Fine.
And will give us more time to think.
Okay. Okay. Sander has been talking about operator forms apart. I think we may get to that. Well, let's take a look at what he's saying here. Yes, I agree with what you're saying about I mean, I hate the hash sub 2 thing. So the question is, what is, if you say, you're giving the example, hash sub 2 ampersand, what could be the operator form of part?
We have extract 2.
Yes.
And that can extract the second element, but it's not very generalizable.
Sander is complaining that that doesn't support all and span. Why doesn't extract support span?
Well, extract was, and this is the discussion in the last topic. Extract was created as an inverse to position, and so additions have been a later thing.
I see.
And all
right. Okay. Well,
lines-
when we get to the inverse of part, let's discuss the operator form of part.
Right.
I agree that an operator form of part would be very nice.
Mhm.
The problem is, I mean, you can't use part itself because it's var args, and it needs to be something shorter. It's not going to be useful. I wish there was an ending for part. The word part, which could be an operator version.
Well, carry of part was another possibility.
What do you mean? Curry like this?
Yeah. Now you can say 2 and apply that to something.
Ethan is saying that there is actually an entity class of curryable Wolfram language symbols. I didn't know that. And that there are 93 of them. I didn't know that had been curated. Interesting. Well, we should make sure as an LCC thing that we've actually got that this is consistent and that we have all the things in the map family here. Like, why is scan not curryable? Oh, it is. Okay. And curry is curryable? Yes, I guess it is. Yeah, there's a slice function in the function repository, I know. Oh, this is a good point from Ride on our live stream, that it would be more sensible to call curry curried than curry. Yeah, I'm not claiming Lucas is saying that curry of part of 2 is ugly, and I completely agree with that. Should it be curry or curried, given that it's reversed?
It sounds well. I mean, I'm so used to curry now, but yeah, curried sounds well too.
Although it may be so obscure. I mean, the whole thing is so obscure. Unless you know, somebody sees this and it's like, unless you know the whole story of, the lambda calculus story, basically, it's just an extremely obscure name.
Yes.
Which is why it'd be really good to have this common thing be called operator or something. Operator. I wish there was another ending.
Mm-hmm.
Right.
Yeah.
Well, maybe we should try this. Okay. All right. Let's keep going here. Okay. Next up, fold while.
Yes. So here, the discussion was whether to return the last successful case or the first failure case. And we decided to look at some examples.
Okay.
And the truth is that looking at the examples, it seems, well, you might still want either of them.
Fantastic. Okay. Okay.
I have the impression it's slightly more useful to know the first failure case, because at least in fold while list, you get both back.
What does while do? While returns effectively, while takes an action and then stops taking the action and returns nothing, right?
Yes, it's like do.
By the way, the typesetting of this is really sucky. And what does take while do?
Take while returns only the successful cases. And that's one of the problems, that the precedent of take while is the opposite as the precedent of nest while.
Okay, and what does nest while do?
It returns the first failure.
Because nest while, otherwise, if the first thing failed, then it's got to return, an empty bag type thing.
Right. That's the third point, the third subsection there.
I mean, can we parameterize having it return?
That's the second section. If you open the second subsection there,
okay.
After the examples.
Okay, hold on.
Yeah.
Find a result limited by byte count.
Yeah, I was trying to find cases in which we would use there. And I think this is useful to construct something limited by size.
Yeah, I agree.
For examples or whatever. And this is a bit like a random, it's like a random walk with geopaths based on something that Michael constructed.
It's amusing. Okay, so what do we want in this case? I mean, it's hard to know in this case.
Well, the min-max computation shows that we indeed went beyond the circle. And I think that's the useful thing to know, to be able to prove that you went beyond. Because otherwise,
I don't know.
you
could equally well say, it could be that there are dragons beyond the circle and you don't want to go outside.
Yes, but somehow this is a confirmation that we did. Otherwise, I mean, how do we know that the next? That's what I was saying. In any case, you could always say, I want either of them.
There's no way to add it in the criterion.
Yeah, I don't see how.
How does this relate to? Doesn't nest while have a thing that looks back at a certain number of previous? It has a way of presenting a certain number of previous results, right?
We introduce sequence fold.
No, it supplies the M most recent results.
Yep.
Mm-hmm. Yep.
Now, doesn't fold? Does fold have a no? Fold obviously doesn't need a I mean, fold has a template for how far to go because that's in the gens. But by the way, I don't understand. In fold, you can elide the seed argument.
Yes, you can.
Whereas here you cannot.
We were planning to do it as well, just by counting arguments. And because it's different from structurally.
Yeah, all right. People on yeah, Lucas is saying that he prefers nest while because it's more similar to fold while. I agree with that. We often apply most to the result of fold while list. Yeah. Nest while can return the nth to last element as well. I see. So that's in fact doing the exact same thing here. That's got an argument exactly like the one you're proposing. An extra n times. So what does that do?
I see. I hadn't seen that. That's very good.
An additional n times after test fails. But now, yeah, okay, so it's equivalent to this.
Right, exactly.
Well, I think that's probably going to be the winner here. And the default should follow. Yeah, it's a 6-argument function. It's horrifying. I mean, it's always possible that some of these, one kind of piece of modernization that we could do on some of these many argument functions like partition and so on is to have an alternative form where there's an association, much like we did in cellular automaton, where there's an alternative form where you can just name everything. I don't think that will be terrible. I mean, that's an LCC activity to try to do that for some of these functions with, lots of different tentacles here. So long as there's an actual name for the arguments. If there isn't a name for the arguments, it's hopeless. All right, so listen, I think the right thing to do here is have this last argument.
Mm-hmm.
It's got to have the same meaning as in this case, which means the default is 0, I think. If I'm not mistaken, right? The default is an additional n times after test fails.
Okay.
Right?
Yes, we will certainly study this part. I should have seen it before.
Okay.
Mm-hmm.
All right.
Okay.
Next, random integer with a step. Yeah, I was suggesting this.
Yeah, and the integer case seems very clear and useful. The only concern is the fact that it cannot be extended to other cases, because I don't think this can be used in the continuous case.
No, but why would we worry about that?
I mean, why wouldn't it work in the continuous case? I mean, this is equivalent to saying random choice of, it's basically range, 1.4, 7.8 in steps of 0.3, and then it's a random choice of those. I don't see why that wouldn't work.
Ugh. That's a very different meaning from random real.
Right. So random real.
Fair point. Okay, you're right. You're right. It's a continuum, and this is not a continuum. Well, I mean, that's the question. What does random real? I mean, random real. What do you think here?
So I think we should simply perhaps have a possible issue or property and relation example explaining the difference, that in the same way that we have a range with the 3 arguments that is discrete, we cannot have a range for a continuous case. It would be an interval.
Yeah.
So it's just that
fair point. By the way, does random real of interval work?
I don't think so.
Probably should.
Perhaps it does. I don't know.
Nope, but that should probably work.
Mm-hmm. Yep.
Okay. Random complex is hopeless. Okay, random prime. That's an interesting one, because I mean, one could indeed want primes of the form 3n plus 1 or something.
Mm-hmm.
Like, do we have any control? N primes. Well, I mean, it's kind of stupid to have any third argument there means that it's a multiple of that third argument, right? Unless it's I mean, you could have a weird case.
Right.
Well, no, actually, if it's 3n plus 1, the random look, here would be the thing. If we say 1, 100, 3, right, that would be primes of the form 3n plus 1.
I don't like it. Sorry.
It's kind of crazy.
Just too, By the way, I was just playing around with the random real with working precision. Sort of has the effect of granularity that you were
is that right?
on. Yeah.
If you go down to sufficiently low working precision.
Yeah, I tried it with working precision 2, for example.
Mm-hmm. Yeah, it's a little different though. It's still a continuum. Just
granular coarse continuum, but yeah, sure. I guess among other things, it means one can already do this sort of thing. It's not something we really need to try to do handsprings to introduce.
Yeah, right. Okay, let's talk about random primes. Okay, and whether we care about having random primes of the form 7n plus 2 and things. I mean, clearly, I don't know how random prime works, but I would suspect that it can much more efficiently generate. I mean, whatever its candidate, how does it generate candidate primes? Does it just pick a number and see if it's prime?
I think for large ranges, yes. And for small ranges, it probably picks a number in a certain way and then calls prime on that.
Okay.
And my vague recollection is that it was implemented in such a way as to get the distribution roughly uniform.
I see. An actual application of the prime number theorem somehow.
Yeah. Just using that as an asymptotic. I'm not sure it was implemented that way. I merely have this vague recollection that I think it was.
Well, it claims not, basically.
Well, it should have been then.
Well, we should discuss that. Why don't you ask Charles, I guess, would be the person for that.
Now, yeah, I think it was implemented by Darren way back when, Klausemeyer.
Okay.
I thought it was.
Okay, so I'm sorry, let's go back to random prime. So, I mean, there's a question of whether prime itself should allow some. Okay, the step argument is not going to happen in random prime. Doesn't make any sense. There's a separate question of whether prime should allow some kind of selector that says, primes of the form 3n plus 1 or something.
My guess is it's not that common a need, and people who need it, we're not going to be able to offer anything that's other than syntactic sugar here.
What is the criterion in the RSA algorithm, for example? There's a criterion on the primes. I can't remember what it is.
I don't remember either. There's something beyond size that
there's some other.
Like P plus 1 can't be smooth or something. Can't have small divisors or something like that, or P minus 1 or both.
I'm looking it up. I think it is some criterion of primes have to be of the form something or other. Anyway, that would be nice to know, because that's a case where we certainly use this. Oh, wow. There's a notion of a safe prime where P minus 1 over 2 is also a prime. It's interesting. Okay. It sounds like an interesting function repository function. To be, let's suggest that for the function repository. Safe prime. Not that we ever want to call a function in the main system safe prime. It's promising too much. But okay, so that may be the criterion there. Okay, various people on the live stream are mentioning, Ethan is mentioning, forgot about uncurrying and partial functions. It would be super cool to do category theory on Wolfram language itself. Yes. What does uncurry do? A partial function, if I'm not mistaken, is the kind of thing we already have, right? I mean, it's something like this, where the full function, yeah, I mean, the partial function is just curry of f comma 3, for example, and until it's been fed enough, it doesn't, right? Until it's what does uncurry do? Uncurry would go from this to f of x of y of v, right? I agree that that is a missing function. I mean, if we said uncurry, oh boy, x, y, z, we can imagine that going to f of x of y of z.
We discussed this at some point, and our conclusion was that because we don't usually then evaluate these type of things in general, we really didn't need it. Do you remember that we were discussing like patterns for any number of brackets and
Yes.
functions to compute
Yes.
how many brackets you have?
Yes. Yes.
So this would require some sort of complete new set of functionality to handle this general case.
Right. Well, what we would want is the curried function analog of repeated, right? Of double blank, for example, saying
exactly.
any depth of currying.
Yeah.
It's a good thing to explore at some point. Yeah. No, I know, and it's something that came up in connection with the Sparkle queries and so on. Of being able to do path, being able to propagate down a path on a graph. All right, I think that's for the future. I mean, I think that we should add that, by the way, to the list of, kind of, yeah, it's just a complicated thing to think about. Okay. Sander is talking about pre of criterion and post of criterion. Yeah, I mean, this whole question about pre and post evaluation does come up in connection with data set. And I think we haven't fully, penetrated how that should work there. But that's a place where it's going to come up. All right, let's keep going. This is hopefully going to be an easier thing now. Listability of DMS functionality.
Yes, so this is something you requested recently, and I realized that it's a bit more difficult than I thought, because the triple DMS list, the DMS string, and from DMS work exactly like the date corresponding functions, date string, date list, absolute time.
Okay.
And the problem is that because we support simultaneously numbers and lists of numbers, listability becomes complicated. So in this example there, where there is the outer product, we see that the three functions from DMS, DMS list, and DMS string are able to take the three formats, and they consistently return the same thing. So for example, DMS list can both take a number and a list, and for the list, it will return the list itself and not go inside and do the three numbers.
I see. Like date list would do, you're saying.
Date list does the same thing, yes. It takes lists and dates, it lists and returns lists.
Yes.
It doesn't go inside and say, oh, I have three absolute times. That's the reason why with date list, etc., we cannot have listability.
Right. Well, maybe we can't have it. Yeah. I mean, is that your conclusion?
Yes. The only thing we can support is, for example, when we feed a geoposition array, then because we know the structure, we can do things. And I've realized that it doesn't work. And probably it should.
Yeah, this should work. Why not?
Exactly. Because there we do know everything.
Yeah, why not?
Mhm.
Okay.
Yep.
All right.
And then this is some sort of beginning of an idea, which is yes. So from the very beginning, version 1, there was part and position, but they are not inverses of each other. And then extract was introduced as true inverse of position.
Yep.
But there is not yet a function that plays the role of the inverse of part. By that, I mean something that can return what you would feed to part. And I think the most useful example is finding the position of a submatrix.
Yes. If it, I mean, it may not. Well, okay, fair enough. If there is such a submatrix, like a block of identical elements.
Exactly. Or, well, they could even be permuted. And that's where my needs come from, because sometimes I have, for example, a multiplication matrix and another one, and I want to relate them. I know they are the same group, it's just that the elements were permuted.
Boy, okay.
So how do you find the relation?
Yeah, but I mean, okay, in the case of position, for example, we can't find submatrices in position.
Right. Position is purely for individual elements.
Well, at a given level, I mean, in the tree, it's an
Exactly.
individual row would work.
Mm-hmm. Right.
An individual column will not work.
Right, exactly.
I mean, how would you find a given column?
Yeah, yeah, it wouldn't work. But with the inverse of part, we could do it. Because
Okay.
you can describe a column like all, 3.
No, I understand. Well, I mean, there's always find part.
And another case that I think is interesting is you can extract parts from a sum, but then it's quite difficult to find a subsum in a sum.
But what would you even return? Because part is Verogs. So how would you return something that is a single object?
Mm-hmm. Yes. And of course, we have the same problem as with position, the fact that the thing might be several times inside. So,
well, maybe we can kill two birds with one stone. I mean, if we have a part operator, then we could return the part operator that is the extractor.
interesting. Yep. Yeah, and if that operator could take sequences like part does, it would be general. Right, exactly.
Yeah. Well, and then part operator would be applied to an expression and would get that part. But now, is that useful? I mean, why not, given that I see that becomes useful because find part operator can have a pattern here, for example.
Right. You would have to say, find this subblock in this matrix.
Well, so that's what expr would be, the matrix.
Right.
And then you'd have this. And then if that block exists, then it would return a part operator that corresponds to somebody who does not have themselves on mute and should. No, okay. Yeah. So, I mean, but now if you want to find a column, let's say I want to find this set of things. Let's say we have a find part operator. Mm-hmm. And I want to find a column, then what I have to do, it's got to have 3 arguments. It's got to find the thing to find, and it's got to have a part pattern, in a sense.
Why?
Because it's got to say, find it as a column. Because otherwise,
I see. Yeah, the level. You have to specify the level at which you are looking for it.
Is it just a level, or is it something more than that?
I think the level should be enough.
Well, you could have a general part pattern.
Like to find a diagonal, for example, you mean?
Well, no, I mean to find only, I want to find it as a column, but it's got to be after column 10.
Well, I was expecting to have some, whatever part can describe already. And part is effectively a tensor product of one-dimensional things. So the level is all it worries about. Well, no, sorry. It worries about multiple levels at the same time. Yeah. So it's more complicated than a single level.
Okay, by the way, part operator in our current world will be equivalent to operator of part, would it not?
Yes. Yes. But operator of part cannot handle sequence. It would have to be a list of the. Yeah, well, you are already writing it as list all comma 2.
Well, there I was, yes. But I mean, in this case, wait a second. This is the curry of part 2, 1 of that. Is this going to fail?
Yes, because it
Because
believes 2 and 1 are different arguments.
yes, I understand. But if I put it in a list, it's going to fail for other reasons.
Right. It will extract the whole matrix permuted.
Yeah, I understand. Right, so part operator could have an extract like innards. Well, maybe a part like innards which has been turned into a list, so part 2 would still work. Part operator of 2 would still work.
Well, no, we could say part operator is vararch inside, like part is. And so we can say part operator of all comma 2.
Yeah, I understand that, but I think what we want here, if we have a part pattern in find part operator, that doesn't want to be vararchs.
I'm still confused about the generality of this part pattern.
I'm just saying that whatever you're going to return, whatever sequences you're going to return, I mean, clearly there isn't a unique, I mean, like all could be all, or it could be the list 1, 2, 3, 4, 5, 6, 7 or something, right?
Yep.
So find part operator would have to have some greediness to it to make it, do things like turn big lists into alls and stuff like that.
But probably in input we can use all, in output it would always return the list.
Why? I don't think that's the right thing. I think it'd be much more useful to have all there. I mean, that's what a find would give it license to do something somewhat heuristic like that.
Well, I mean, all has a different meaning depending on what it's been applied to.
It does, yeah, it does. But I mean, that's the question of what generalization you're going to want. I mean, this is most interesting if this was just being applied back to the exact same thing again, then why would you do it at all? You know what you can find with this operator, right?
Well, yes, but I was thinking of the case in which you know something is inside, but you don't know what it is. And that's the interesting.
Yeah, but by the time it's where it is, then you don't want this crazy part operator thing wrapped around your where it is thing.
Why not? If it's a sequence, I mean, I preferred the part
No,
operator.
if it's a sequence, yes. But I mean, look, the alternative would be to have find part, and that returns a list. Oh boy, which you'd then have to say part operator of that list applied to the thing. You couldn't give it to extract because extract does something different.
Right, exactly.
Well, I mean, one question is find part actually writable? You know, in other words, is there an obvious calculus of when you can use spans, when you can use alls, stuff like this?
I would say
Yeah.
say the first thing is to write the function that returns only numbers and lists of numbers. And then there would be a second step of trying to simplify those results.
But by the way, yeah, but actually, look, the toFind thing, if it is the complete column, if the specification is like blank blank, for example, it's pretty weird to give 1, 2, 3, 4, 5, 6, 7 to represent the blank blank, because the blank blank is really asking for an all. If on the other hand what you give is A, B, C, D, then fine, you can return 1, 2, 3, 4. See what I'm saying?
Yes, in some cases it would be 1, 2, 3, 4, but permuted. So we cannot use all day.
Why would it be permuted? I don't understand that.
Yes, this is the example I was saying before. If you have two multiplication tables, which are the same group but different orders of elements, you know you can go from one to the other by
permutation. Yeah.
With permutations. So finding those two permutations could be then different in different axes would be great.
I'm very confused by it. I'm sorry. You mean that the row permutations or the column permutations?
Yes, in general, I mean, for groups it will be the same because it's the same ordering for the same list of elements.
Yeah. Okay, but let's come back to this. Hold on a second. So what you're saying is, okay, there are two things at issue here: a part operator and something for trying to. I mean, look, why don't you see whether find part and part operator make any sense?
Mm-hmm.
Or find part operator.
Yep. I like very much this idea of returning a part operator.
But do you think it should be Verogs, or do you think it should have a list inside it?
I'd prefer to have, well, for example, we have indexed, which unlike part uses a list. So indexed is effectively like part, but with a list. And it stays there happily symbolic. And that was the main reason to introduce indexed, because part complains about part X.
All right, so Sandra is telling us to look at slice in the function repository. Let's go ahead and do that.
Mm-hmm.
Oh, this is a tally production. This formatting is really sucky. Devin, another thing to complain about.
Yep.
Yeah, I mean, it's an operator form of part.
Mm-hmm. Right.
I have no great thrill I just don't really like slice very much because it's another metaphor, you know, part, slice. Why would you call it slice? It's doing something that's just like part. And I agree with Ethan that it's better to extend an overload rather than to add symbols, but sometimes we you know, unfortunately, part is Verogs, and we can't have part of one argument mean the operator form. in a perfect world, if one were to replay history, we probably would have made X double bracket AB turn into X part of, in a perfect world, if history were to be replayed, we would probably do this. We'd probably say that goes to part of X, comma list AB. But that's not what we did. Ethan says, sure you can, but I'm not sure what that's referring to, unfortunately. I don't think you can check the first argument because while I agree, okay, so the claim, no, it can't work because the operator form of part has, yeah, exactly. You can't make that work unless you have a list form of what's inside a part, because a first argument, yeah, it just can't work. I mean, the problem is that this is an elided form. I mean, in other words, you might have ended up with something which is and there may very well be code that does this, where if it's a matrix, it could have the first element here, but if if it's a vector, but if it's a scalar, it has 0 extractors, i.e. part of 2, i.e. 2. I think part operator is the only possibility. And I don't think there's any plausible syntax for it that would be. Yeah, but okay. So imagine that, and imagine find part operator returns a list of part operators, right? That's what it's got to do.
Right.
Yeah, it's another good reason to not have. And then now, to apply that list of part operators, right? It's a little bit funky, right? Because you've got a list of part operators. And you're going to apply them to an expr. And what do we have to do here? Well, it's our friend, the unused function, through.
Well, we could even think of generalizing extract to do that, because the key point of extract is the multi-object nature.
Yeah, that's true. But so you're saying the alternative would be extract expr, comma, part operator, blah, 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 blah.
Right.
But notice that part operator, I see, when you write a piece of code, you can write part operator. Well, so what you would write is, what would you write? You'd write something like select hash greater than 2. And then you would write @ star part operator, is that right? If you want to get, and then that thing, well, let's say S here, applied to XY, would be that, which is the right thing. I mean, it's a lot more typing to type part operator than hash sub 2, although it's less. I mean, one could imagine if this got popular, one could imagine some shorthand for this thing. Well, let's do the experiment. I mean, this is a little bit weird here.
Mm-hmm.
But maybe it brings through out of the shadows. Somehow, a lot of these functional programming constructs, I guess these higher order. I mean, it's really a question. I mean, it's an interesting world being built up here, and it's an interesting thing for people to get experience with, using all these different things and getting familiar with them. It's kind of it's like so few universities now have courses on functional programming, but there's a lot to teach. Anyway, all right. Anything else we should cover here? I think it's worth trying to implement some of this stuff and see whether this actually makes any sense.
Mm-hmm.
Part operator and find part operator. Okay, I think we've achieved a bunch of useful things here, and thanks to folks on the live stream. I'm sorry, I'm coughing slightly, and I'm still slightly subdued because I was sick. So probably by the beginning of next week, we will be in full energy, and we have many design reviews coming up next week. Lots of functionality for 12.1. So stay tuned. Hope to see you all there. All right. Thanks a lot. See you later.
Wow.
Bye.
Bye.